everyone, welcome to Samadhan Life Science. Today's video is about deviation in bond angles. This is a part 2 of our last video, hybridization. So let's start with a quick recap. Hybridization gives us the ideal molecular geometry. For example, sp hybridization gives us linear geometry, sp2 trigonal planar, sp3 tetrahedral, sp3d trigonal bipyramidal, and sp3d2 octahedral. And these are the ideal values of bond angle that comes from this hybridization. Now, in real molecules, the bond angle value deviates from these ideal values because of some factors. So let's discuss them. The most important factor among them is presence of lone pair in the central atom. So according to VSEPR theory, the repulsion between two lone pairs present in the central atom is maximum. Then comes the repulsion between lone pair bond pair, and relatively bond pair repulsion is minimum. Now let's take these three molecules as an example. So for the molecule CH4 methane, we saw in our last video that the central atom carbon is sp3 hybridized and all the bond angles are same, 109.5 degree. Now let's take the molecule ammonia. So for ammonia, this is also the central atom is also sp3 hybridized. Why? Because there is three bond pairs, three nitrogen hydrogen bonds and one lone pair on the nitrogen. So total is 4 electron pairs are there. So we will take this as sp3 hybridization, and then this lone pair will occupy one space for one bond pair, and this lone pair takes more space, and this push the bond pairs closer to each other away from it. So the lone pair on the nitrogen push the other three bonds closer to each other because it repel more. Lone pair bond pair repulsion is more. So that's why the bond angle is lower here than this ideal value, and the value is 107 degree for this molecule. And let's take the third molecule, which is water. So for water with the central atom oxygen, two hydrogens are attached and then two lone pairs are there. So we already saw that the repulsion between two lone pairs is maximum. So this will push the bond pairs more away from the lone pairs and closer to each other. So the bond angle will be lesser, 104.5 degree. So all these three molecules are sp3 hybridized, but the bond value of the bond angle is different in these three. So let's take other factors into consideration. First one is size of central atom, and this example of water and hydrogen sulfide we already discussed in our last video that oxygen is smaller, and so the structure is more compact. The lone pairs are situated more compactly to oxygen, so this makes the bond angle lower, 104.5 degree, lesser than the ideal value, but this is higher than H2S because sulfur is larger. So the lone pairs in sulfurs are more diffused. So they push the sulfur hydrogen bonds more closer to each other and the bond angles become lesser, 92 degree. The other two factors are electronegativity of the central atom and presence of pi bond. So if we take the example of these two molecules, SO2 and O3, so both of them are sp2 hybridized. How? Because sulfur has two double bonded oxygen and one lone pair. So this lone pair repels these bonds, but these bonds are pi bonds, so the electron density is more than normal sigma bond, so these also repel with each other. So the bond angle is almost ideal, 120 degrees, but in O3 one of the bond is only pi bond. and the electronegativity of oxygen is also greater, so the lone pair is closer to of the central oxygen, so that it also repels the bonds. So here the bond angle is lesser. See, now let's take the example from our previous year question. So here they are asking that among CO2, SO2 and O3 which has the smaller bond angle. So for CO2, the central atom carbon is sp hybridized with a bond angle 180 degree. But for SO2 and O3, we already saw that for SO2, sulfur is sp2 hybridized with around 120 degree bond angle, and for O3, this is also sp2 hybridized but is smaller with smaller bond angle. So the answer here is O3. Now, let's take the last question for today, which is match the species with the central atom hybridization. Here we have four molecules. Let's take them one by one. So, for I3 minus, with the central atom iodine, two iodines are attached, but iodine also has three lone pairs. So, we will consider three lone pair plus two bond pairs, total five pairs of electrons. So this should be sp3 dehybridized. So now if we draw the structure, then iodine, and we will put those two iodines to axial positions and put those three lone pairs in our equatorial position of sp3 hybridization, because in the equatorial position the bond angle is larger, 120 degree, right? So the repulsion will be a little bit less. So this is I3 minus, and the shape is linear, but the hybridization is for I3 minus sp3d. Next molecule is PCl3. So phosphorus has one lone pair and three phosphorus chlorine bond. So PCl3 is sp3 hybridized, and then BF3 is sp2 hybridized, the central atom boron, and for CO2 carbon is sp hybridized. So I hope this clears for you the concept of bond angle. Thank you for watching today. See you in the next video. Bye bye.